Welcome class 12 to the first day of revision series. We are taking with the chapter solution. Starting with the definition of solution. Solution are known as perfectly homogeneous mixture of two or more components. Homogeneous mixture of two or more components is known as solution. Then we have two parts from which solution is made of. First is solute and the other one is solvent. So solute is that component of the solution which is present in the lesser amount, that is present in lesser amount, and solvent is that component of the solution which is present in the larger amount. Now solvent is the one which determines the state of solution. So on the basis of different type of solution, we have on the basis of different type of solvents, we have different type of solution. So let's have a quick recap on types of solutions, starting with the gaseous solution. So gaseous solution are those solution in which solvent is gas. So solute can be either solid, liquid or gas, but solvent will be gas only. Some examples for these. First, the solid that is dissolved in gas, like iodine vapors in air, dust or smoke, etc. The second, for liquid dissolved in gas, water vapors in air. And for gas dissolved in gas is air. Second type of solution is liquid solution, in which solvent is liquid but solute can be anything. Solid, liquid or gas, but your solvent will be liquid. Example like salt or sugar solution. Then liquid in liquid, alcohol in water, and gas in liquid like aerated drinks. Or oxygen in water. Third one is solid solutions, in which solvent is solid. So again we have solute like solid, liquid, gas, and solvent as solid. Example, solid in solid alloys, Hg in silver, or zinc amalgam, and gas in solid like solution of hydrogen, platinum. These are some examples of different type of solutions. Next, we will study in details regarding the different method of expressing concentrations of solution. So for this chapter we will be using some specific concentration terms. For one, starting with the mass percentage. So mass percentage, we define it as given mass upon the total mass percentage, that is W1 plus W2 into 100. The next concentration term we are going to study is mass fraction. That is given by 4 x1 is W1 upon W1 plus W2. Then the next term is molarity. Molarity is defined as number of moles per unit volume in liters, or we can say number of moles that are in ml of liter is 1000, or weight of solute divided by molecular mass of solute into में volume of solution in liters, where the volume is of solution. The next term is molality, that is represented by small m, that is defined as number of moles of solute that are present in 1 kg or kilogram of solvent. We can say for solute, given mass of solute divided by molecular mass of solute into में weight of solvent in kg, or if we use gram, then we will multiply the term with the 1000. The next term is mole fraction, represented by xi, that is x1 equals to n1 upon n1 plus n2. So these are the concentration terms we are going to study in this chapter. Now starting with the first topic of this chapter, that is solubility. Now, solubility is known as the maximum amount of solute that can be dissolved in 100 gram of solvent. Next, what are the factors affecting solubility? So factors that affect solubility are, First is nature of solute and solvent. It is like polar solutes will be dissolved in polar solvent. Like dissolves like. Polar solute will be dissolved in polar solvent. Next, the effect of temperature. There are different type of terms. For example, if an reaction is or the dissolution process is endothermic, that is the enthalpy of solution will be greater than 0. For such process, the solubility increases with rise in temperature. And for the process like exothermic, so enthalpy of solution will be less than 0. For such processes, solubility decreases with rise in temperature. Next is the effect of pressure. The effect of pressure. Pressure does not have any significant effect on the solubility of solid in liquid, as these are highly incompressible. The next factor, if we specifically define for the solubility of gas in liquid. For solids in liquid, no such significant effect. Now the next is solubility of gas in liquid. First, effect of pressure. As you know, gas being dissolved in liquid, the first and foremost factor that will be affecting the solubility will be pressure. So regarding the pressure, there was a scientist known as Henry's. He given a law that is known as Henry's law, which states that the partial pressure of a gas in vapor phase will be directly proportional to the mole fraction of the gas. We can say P will be directly proportional to X of gas. Like we can leave anything in proportionality, so we use a constant here that is known as KH. KH is known where KH is Henry's constant. Now what is the significance of this Henry's constant? For different gases at a particular temperature, the value of Henry's constant will be different. The value of KH is different for different gases at particular temperature. Second, higher the KH, lesser is solubility. जितनी ज़्यादा KH की वैल्यू होगी आपकी सोल्यूबिलिटी गैस की लिक्विड में उतनी ही कम होगी. एंड सेकेंड इज इफेक्ट ऑफ टेम्परेचर. नाउ dissolution for gases in liquid is a exothermic process. Then according to the Le Chatelier's principle, solubility should decrease with increase in temperature. So these are about a basic about the solution chapter. In next video we will be discussing about the Raoult's law, Turtle's law, and the nature of ideal and non-ideal gas along with the isotopic mixture, colligative properties, and the abnormal mass. So thank you and stay tuned for new video.